looking at the trends of the periodic table. And last lesson, we actually colored our periodic table into 3 groups. But for today, I was using a blank one so that I can write all over it and not have the colors distracting you guys. But we did color our metalloids, our nonmetals, and our metals. So we're going to be marking this periodic table up today. And the first thing I want you to do is we're going to get out a pen or a pencil. And we are going to write down what we call group or family names. So I'm going to turn it sideways, and you should too. And I'm going to do some zooming here. And we're going to start with this left side. The first thing I want you to do is I want you to label this column alkali metals. That's A-L, K, another A, L, I, and then metals. If I could spell, it'd be great. Now, this family contains all of the elements in this column. So this is a family, and it's called the alkali metals. The next family is alkaline. So A-L-K-A, L-I-N, alkaline, and they're called earth metals. So we're just going to write alkaline earth. Let me see if I can get this darker for you guys to see. Now, our giant section here in the middle, this big section right here, we are going to label it as transition metals. And that's because they are transitioning into the metalloids, so transition metals. And down here at the bottom, we have the lanthanides and the actinides, and these are called rare earth metals. Rare earth metals. Now, I've taught a few classes, but I'm going to kind of remind you guys. This right here is showing us that this piece of the periodic table should be right here. Now, the only reason they've put it down here, and this is probably a silly reason, but it is the real reason, is if we had this entire grouping of rare earth metals in here where it belonged, the periodic table would be too long to fit on a normal size piece of paper. So printing would be difficult. So they take it and pull it down here to make everything fit nice and neatly and the trends and the groups to work out. So we're going to turn back sideways now. And our first group here starts with boron. So this is actually called the boron group. Now, I know, creative name, right? Now this one starts with carbon. Again, another creative name. This is the carbon group. Next, this one starts with nitrogen. So again, super creative. We've got our nitrogen group. And then this one starts with oxygen. So that's our oxygen group. And now we're going to change it up a minute. This one does start with fluorine, but these have a special name. And these are called halogens. Now, these are actually what we use in light bulbs now to make the bulbs last longer, halogen gases. And then last, this starts with helium, but we're going to call this our noble gases. And they're called noble gases because they do not bond with any other element. So we're going to turn this around, and I want you to draw a crown. Like a king. We have our crown here. These are our noble gases. They do not bond with any element. All right, the next thing we're going to look at today are going to be our groups and our periods. Now, our periods are these numbers right here on the left-hand side. So we have period 1, period 2, 3, 4, 5, 6, and 7. Now, for notes today, we've got to label our lanthanides and our actinides. So I'm going to take a separate pen or pencil, different color, and this one actually is period 6, and this one is actually period 7, because remember, they've come out, let me move that up, they've come out of our periodic table. So we're going to go sideways again, and I want you to write, starting down here at the bottom, the word periods. Now, periods tell us how many energy levels an element has. So how many energy levels an atom has. And we're almost at the end. So, remove that where you can see it. Let me zoom out. So periods tell us how many energy levels an atom has. So for instance, these elements here in period 1 have 1 energy level. Period 2 has 2 energy levels. I want you to be marking the periodic table with me. 3 has 3 energy levels. And 4, again, has 4. 5 is going to have 5. And we're going to get pretty big here, so I'm going to have to overlap. 6 will have 6 energy levels. Let's see if I can do it better this time. 1, 2, 3, 4, 5. Again, I'm going to have to overlap. And 6. And then 7 is going to have 7 energy levels. I'm going to bring it down some. 3, 4, 5, 6, and one more makes 7. So if you notice, as we go down this way, the atoms are going to get bigger. I want you to know that periods are also called rows. So it's very important to remember they go this direction. They are called rows. So we're going to write the word rows. And they go across. So just like you're reading a book. So period 1 goes across and it's hydrogen and helium. Period 2 comes across. Lithium, beryllium. Boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3 goes across. So these go from left to right. So let's go back down here. Next to the word periods, we're going to draw a double-sided arrow. These are rows. And they go left to right. So I want you to change your color. And we are now going to talk about the numbers that go across the top of the periodic table. So I'm going to go with orange here. Now, the numbers up here are called group numbers. So up here at the top, above the word star, let's write groups, which are also called families. So we've already kind of labeled our family names. And these tell us how many valence electrons we have. And we're going to put an E minus so we don't have to write E electrons. Now, a valence electron is basically the last electrons on the outside shell. So let's put a parentheses and put electrons, so E minus, on the elements outer. Let me go over, sorry. And then energy level. Now, groups are really important. They're called families because just like our families, we have characteristics similar to our parents. So, groups, for instance, like the alkali metals here, they behave similar when bonding with other elements. The alkaline metals behave similar when bonding with other elements. So just like you act like your parents or your siblings, your family, elements act like their family. So they have similar characteristics. So let's look at these numbers. Like group number 1. So this is a group, so everybody circle the number 1. Group number 1 has 1, and we're going to put a dot, valence electron on its outer energy level. Group number 2, circle the 2, put 2 dots. Group number 2 has 2 electrons on its outer energy level. And then if we kept going across, you could. 3 has 3 electrons on its outer energy level. Now, the reason I'm not going to fill all of these in right now is because we really only have to think about the first 3 periods of the periodic table. Okay, so it's almost like this one's not there for us this year. I mean, it's there, we're going to use it. But when you get over here to 8, 9, and 10, the rule about valence electrons changes a little bit. And so we're going to save that for high school chemistry. So I want you to move across the transition metals. I want you to go over here. Notice on this side it's groups 13, 14, 15, 16, 17, and 18. These are their group numbers. But to determine their valence electrons, we take the 1 away. So group 13 has 3 valence electrons. So write a number 3 in the circle, and let's put 3 dots. See how it says 3A right here? Not all periodic tables say that, but that tells you their valence electrons. And some more details about the periodic table. Right here, let's put a 4 in the circle, because 14, take the 1 and cover it up, tells us we have 4 valence electrons. So we're going to color 4 dots. Group 15 has 5 and 5 dots. Group 16 has 6 and 6 dots. My dots aren't showing up very well. Group 17 has 7, so 7 dots. And group 18 has 8, but there's one that's special, and we're going to talk about that one in a second. So I want you to draw a line right here. And I want you to have the number 8. And we're going to put 8 dots. Now the reason I drew it out to the side is because helium's special. So let's kind of color around helium for a second. Helium only has 2 valence electrons, and that's because helium's number is 2, so it can't have 8, so it only has 2 valence electrons. So helium is special, it only has 2, but everything below that has 8. Okay, I want you to come back up here. So where we wrote our definition of groups or families, I want you to remember that groups are columns, and they go up and down. So we're going to write the word columns, and we're going to put our arrow that goes up and down. And then we're going to change colors one more time. And we're going to talk about something that we call reactivity. Reactivity. So our periodic table is set up in so many different ways. So we have our metals, our nonmetals, our metalloids. That's one way. We have our periods, the rows that go across. We have our groups, valence electrons going down. And another way the periodic table is set up is by reactivity. So over here in the bottom corner, I want you to write the word reactivity. And reactivity means how it's going to bond with another element. So let's write how it bonds. Or, the other word, reacts when combining with other elements. So let me zoom in for that. So reactivity, how it bonds or reacts when combining with other elements. Now remember we talked about the noble gases and how they're special, and we put a crown up there for them. Well, that's because our outer energy level is full. Its electrons are happy. Its valence electrons are happy. So our noble gases are what we call non-reactive. They do not bond with any other element because they are happy. And they don't want to lose or gain electrons because they have everything they need. So they never, ever, ever bond with another element. Now, our halogens right here have 7. They want 8. They want to have 8. So these are going to be what we call super reactive because they're going to want to steal from other elements. They're going to want to combine and steal from other elements. Now, let's go to this other side, our left-hand side. Our alkali metals are also what we call super reactive because they only have 1, but they want to have 8. So I want you to think about something. If these have 1 and they want to have 8, and the halogens have 7 and they want to have 8, they would most likely combine with an alkali metal to make 8 because 7 valence electrons plus 1 valence electron makes 8. Oxygen group also wants to have 8. It has 6. So I want y'all to think about something. Water is H2O. So I'm going to write that right here just for a second. H2O. What that means is I have 2 hydrogens and 1 oxygen. So I want you to think about this. Oxygen has 6 valence electrons right here, and hydrogen has 1 valence electron for the one hydrogen and another valence electron for the other hydrogen. So look at that. You've got 6, 7, 8. So water is a stable, happy compound because it's made 8 in its outer energy level. So if I said fluorine is going to bond with what element? So we have 7, we want 8, so it would find something to bond from over here. Now, noble gases, remember, they are not reactive. They react with no one. All the metals and other groups here in between are going to be called what we say moderate reactive or low reactivity. They're happy, but they still want some electrons, so they're still going to bond. It's just they're not going to be as violent. So we're going to see a video clip next of how our most violent elements react, and that's going to be our alkali. Remember, they are super reactive. And we're going to see how they react with another element or compound of water. I circled francium right here because francium is the most reactive element on the periodic table. The whole group is super reactive, but francium is our most reactive element. We might add that down here at the bottom as, like a little clue there. And it is the most reactive element of all time. So we're going to put francium equals most reactive element ever. Now, we cannot, purchase francium with our teacher licenses we have right now. And francium is kind of unstable. So once you do get it out of the earth where it belongs, it's going to start decaying pretty quickly. But if we could get a piece of francium, it would destroy a boat in the ocean very quickly if it was combined with water. And that's going to make sense in just a second after you watch your little video clip. So, we colored it the other day. Now we've marked it up with our periods, our groups, our reactivity, and these are what we call trends. So how the periodic table was set up, because remember, Dmitri Mendeleev only knew that there were 63 elements, and he guessed that others existed. So our periodic table today is now full of over 100 elements, because he had those guesses. Like, he might have had oxygen, but he didn't have fluorine, and he knew about neon. So he could guess that if oxygen was 8 and neon was 10, well, there's something that belongs in the middle. And he was able to do that because of the trends that he saw in the periodic table. So these should already be glued in your journal, but if not, I want you to go ahead and glue them in now. And we are going to also put in our journal today this brochure. Let me show you mine. It's already in my journal. But you picked this up on your way in today. Let me zoom out for you. And it takes what we just wrote on our periodic table and breaks it down into sections, because I know sometimes when you look at, and I'll show y'all my complete one, when you look at this, you go, holy smokes, that's a lot going on, and I don't know what it's talking about. So we took all of this and we put it in a little brochure for you. So we have our periods, which are rows, and they tell us how many energy levels. Our groups, which are columns, tell us how many valence electrons. So, it's almost like a puzzle. If I said, find an element that has, let's say, 5 valence electrons and 2 periods, well, it's kind of like locating on a graph. It's like longitude and latitude. So we would go to 5 valence electrons and period 2 energy levels. So our element would be nitrogen. So that's what it means here when it says putting it all together. It's how we would use it to locate the atom on the periodic table. So let's practice a few. if I say I have one valence electron and I have 3 energy levels, 1, 2, 3, I am sodium. Okay, so let's practice them on our own. I have 5 periods and I have 3 valence electrons. 5 periods, 3 valence electrons. Find your element. So 5 periods, 3 valence electrons. So like our longitude and latitude, we're going to meet in the middle, go down 3, across 5, and you should be at indium. Let's do another one. I have 2 valence electrons and 1 energy level. Sorry guys, ignore that bell. I have 2 valence electrons and 1 energy level. This one's a tricky one. So here's our 1 energy level. So we have 1 valence electron. We don't have anything here, so we've got to come across and look here and see that we have helium as our 1 energy level and our 2 valence electrons, helium. Okay, let's do one more. Let's see. I have 6 periods and I have 5 valence electrons. 6 periods and 5 valence electrons. Let me give you a second to find it. So period 6, 5 valence electrons. So we're going to come across and we're going to meet, and it should be bismuth. So we're going to use that stuff today, or these periodic trends to help us with our lesson. So one more time, you got this glued in, we've got it colored, and we've got it all marked up with our stuff. And then we should have glued in our brochure, and these things are going to help us with our work today. All right, we'll get to the work in just a second.